In this unit, we're going to talk about why sometimes plants, even if we propagate them vegetatively or asexually, don't always look identical. A lot of times this has to do with mutations, hence our title. But don't act like this isn't what you thought about when you saw Freaks and Mutants. You know it is. But back to plants. There are some reasons why your plants that you asexually propagated might not look identical that isn't necessarily a mutation reason. And the first reason is a concept we call phenotype. Phenotype is the interaction of the plant's genotype and its environment. Which brings us to the next question, what is the genotype? Well, you can see it's defined here as the genetic constitution of an organism, or the sum total of all the genes present in an individual. In short, this would be the plant's genetic code. Now, the genotype is going to code for certain characteristics in that plant, but there's also interactions with the environment that can cause it to look different. So that's phenotype. So here are some examples of some environmental factors that can affect the appearance of clones or asexually propagated plants. Soil type, soil fertility, moisture, temperature, cultural practices like if you're pruning the plant or maybe the time of year you plant it in the ground outside or something like that. These are all cultural practices. Year, you may have an atypical year weather-wise or pest-wise, and that might make your asexually propagated plants look different from the plant you originally propagated them from. Basically, the whole genotype by environment interaction, which again is phenotype, is the whole nature versus nurture argument. Nature in this case would be your genotype, what the plant already is genetically coded to look like, and nurture would be phenotype, how the interaction with the surrounding environmental factors affects the appearance of that plant. So in the picture here you can see that these are all clones. Each clone of the plant has a certain letter, so A on the left and A on the right can be assumed to be genetically identical. They have the same genes, they have the same lighting, but you can see that one set of plants doesn't have enough nutrients and the other set does. So this is pretty common sense. You would expect that the plants that are deficient in nutrients will look different than the ones that are not deficient in nutrients, even if they're genetically identical. Here's one of our classic examples of phenotype. These are both red delicious apples. Now, which one of these is what you think a red delicious apple typically looks like? Most people, if you're apple eaters, will pick the one on the left. When people think about red delicious apples, they usually picture them as having those lobes down at the base. It's what helps you identify it as a red delicious apple. Now, all red delicious apples are clones. All red delicious apple trees have been asexually propagated from the same material, so all red delicious apples should be genetically identical. However, here we have two red delicious apples and they do not look identical. So what's going on here? Well, this is a phenotype thing. In order to get those lobes on the base of the apple, you have to have cool night temperatures. They have to be below a certain temperature. So if you grow red delicious apples out in Washington State, you have those cool night temperatures consistently and you get the lobes forming on the bottom. So that's our apple on the left. However, we also grow a lot of apples here in North Carolina, and if you grow them in North Carolina, because our weather fluctuates so much and we don't always consistently have cool night temperatures, we don't get the lobes forming on the base of the apple. So they're genetically the same, these two apples, but they've been exposed to different kinds of temperatures, and so when you don't have the cool nights, you don't get the lobes. So the apple on the right is a red delicious apple that was grown in North Carolina. So that's an example of phenotype. Now, just for your information, if you go buy red delicious apples at the store and you see one that says it's been locally grown but it has the lobes on the bottom, it's not a lie. Because they know that you, the customer, expect to see those lobes, they actually spray a hormone on red delicious apples that haven't had sufficient cool night temperatures to make those lobes on the bottom. So they spray it with a growth hormone that will make the lobes form. And so with that, we're going to end this part of the Freaks and Mutants material.